introduce our resource person today before we begin the session. Professor Dr. Masood H is a professor and head Department of Statistics at the University of Lucknow, UP. Previously, he served as a Dean Research, Pan-Area Chair, Decision Sciences and Analytics, Chair IQAC, etc. at Jaipur Institute of Management, Lucknow. He has been associated with Great Learning also. He has a PhD in Mathematical Statistics and was a CSIR UGC Fellow in Mathematical Sciences at Lucknow University. His area of expertise is machine learning, analytics, data science, multivariate data analysis, decision modeling, optimization, research methodology, etc. The list goes on. He has wide experience in consultancy and also has taken more than 300 FDPs as well as MDPs in various areas. He has also co-authored the famous book on statistics known as Statistics for Management, which is a Pearson publication. He has more than 50 research papers to his credit in various internationally acclaimed journals and has 565 Google Scholar citations, including 12 H index and 12 I-10 index as of today. So without much ado, I request Dr. Masood H. Siddiqui to kindly begin the workshop today with our participants. Over to you, Dr. Masood.
Thank you, Dr. Famina. Thank you, Dr. Vandana. So I am starting the session. Some part may be common with the first one because that part also covered the basic parts, right? So kindly bear that, and if that looks to be very common means, then kindly indicate in the chat. I will just skip that part. And I am sharing my PPT, and don't worry about the PPTs. They will be shared after the session because I will be writing something. So, and you can type your questions in the chat box that can be taken later on. So since I am using the dual screen, so it would be good that kindly do indicate when there is some issues with the sharings. So anyone can type yes or no if there is some issue with the screen sharing. So now I have shared the screen. Hopefully this is there in front of all of you. That is the exploratory data analysis, right? Though this a bit of this part might have been covered yesterday also, but I'm starting with that part because some issues are involved that can be taken as we move to the future lectures, right? So here, as you know, the word is the exploratory data analysis. Here, the first word is related to the data. Data is actually the numerical information. So everything that we are going to do is basically related to some type of information. And what do we basically mean by the analysis? Analysis is try to find out meaning from the data. Obviously, this meaning would be different for different people for different purposes, right? So we try to have meaning from the data. And why the word exploratory? It is actually the first acquaintance. It is the first phase of the researcher or the analyst with the data. So that's why I have used this word, that is the exploratory data analysis, right? As we know, that the concept that we are going to cover is related to some type of numerical information, and here we are considering the data. So what is the premise of or the underlying concept of this? It is that everything is to be converted into the data. Actually, it is related to, there are two types of approaches so to answer any question. Right? There are two types of approaches to answer any question. And one approach is data-driven decision making. And the other approach is known as Hippo algorithm. Hippo algorithm is highest paid person's opinion. Which is actually based upon the opinion of the individual opinion of the decision maker, individual opinion of the company, individual, that is more related to subjectivity. And this data-driven decision making is also known as objective and scientific approach for the analysis. So we are going with this type of data analysis. So whenever we get the data in a normal research or even in analytics, data may be in a defined format that is known as structured format, or data may be unstructured format. So in the structured format, we basically means our data would be somewhat in this format, in a particular format, whereas some information related to columns and some information that are related to the rows. The convention is the variables or the features are put in the column and the sample, just a moment, and a sample or the cases, they are put on the rows. Okay, right? So this type of data is known as structured data. So we are primarily going with this data that is known as structured data. After that, data can be divided into two parts. One is the cross-sectional data, that is the one-time data, which is very common to the data related to the surveys. The another one is the time series or the longitudinal data, where the data is being collected with respect to some time element, like the position of a particular share for the last 1 month or the last 1 year, that is arranged as per the some time element and arranged as per some date or the year, or annual production of the steel company in India. So this type of data is known as longitudinal data. Panel data is the combination of both. That is the cross-sectional data as well as longitudinal data. Means, suppose we are considering some economic phenomena. So the data that is related to the economic phenomena at a particular point of time is the cross-sectional data. And when we have multiple variables that are being considered for different point of time, that becomes the panel data. Now, data can be metric and data can be non-metric also. This I will be dealing in more thorough manner. Metric primarily means data is measurable in nature. That is also known as quantitative. And the other one is the non-metric data, where the data is actually the categorical data, where we have data in the form of category. So numbers will always be there. We have to find out, we have to consider whether that number is denoting something used for the measurement or something that denotes the categorical aspect. So accordingly, we have four type of scales are there that we are going to consider. That the first one is the nominal scale, which is the lowest category scale. Why this is known as the lowest category scale? Because it provides us the minimum information. Here, numbers are used for the labeling purpose only. Numbers are used for naming or nomenclature purpose only. So this type of data is known as nominal data. Our enrollment number, right? This is one of the or the room numbers, or the numbers of the coaches, numbers of the players, jersey, all are examples of the nominal data. And even in some situation, we denote categories. So to denote, so to use numbers, so to denote the category. Just like the example is, we can have male, we can have female also. So we can put 1 or we can put 2. So this is a categorical. Or we can take some other examples. Suppose the person is using brand X, other person is using brand Y, the next person is using brand Z. So we can assign the codes or the category like 1, 2, 3. Right? So these are the nominal data. Here numbers doesn't reflect anything. Number doesn't reflect the measurement. So this is non-metric data. Nominal is a non-metric data since it doesn't represent anything. So there are only one mathematical operation, that is counting or frequency. So only one mathematical operation is there, that is we can use only count or we can use frequency. So if data is in this format, then we use mode so to represent the measure of center tendency. Further, there is no measurement, so we don't have anything that is related to variable measurement of the variability, no measurement of variance. Right? Related to relationship, here we use, I will be dealing this tool, we will be using cross-type analysis. And for testing purpose, we primarily use non-parametric test. So these are the examples of the nominal scale where the numbers are used just for the naming purpose, right? And there is no other operations except the counting or the frequency. Then we have ordinal. Ordinal data means it is a rank or ordered data of lowest kind. What do we mean by the lowest kind? Means as we move forward, then interval and ratio also consider the ordering, right? But in the ordinal data, we have only ordering. Means there are only two characteristics. One is the naming, other is the order, right? So the best example is rank. So if ranks are the best example of the ordinal data, right? So this is the example of the ordinal data where we use, right? Since here ordering is important, so we can count the numbers, means frequency is there, as well as we can arrange data in increasing or decreasing sequence. So if data is in this format, then we can use quantiles. Right? And for the center tendency, we can use median. For dispersion, we can use quartile deviation or interquartile rate, which is the difference of Q3 and Q1. Right? And for the relationship purpose, we can use Spearman rank correlation. We can use Spearman rank correlation. We can also use cross-tab also, right? So to examine the relationship. And here also, primarily we use non-parametric method. So this is also non-metric data. So these two categories of data belongs to the part that is known as non-metric data. So any question up to this point, or the things are clear to all of you? Because the tool that we decide that will be taken up in all the future classes is based upon the type of scale that we are going to use. Okay. So hopefully these things are clear to all of you. Okay. Then we take another scale that is known as interval scale. This interval scale has three characteristics. One is name, order is there, and there is a concept of difference is there. Like in the rank, there is no concept of the difference. If we consider rank 1, rank 2, and rank 3. Suppose we are taking an example of the performance of the student. Suppose the first student has secured 85%, second student has secured 83%, and the third rank students have secured 73%. So here, as you see, the difference is one only. But when we come to the magnitude, so the differences would be different, right? So it does not have the difference property. But for the interval scale, we have difference property also. So the most common example is we use Likert scale. That can be from 1 to 5, 1 to 7, 1 to 9, 1 to 11. Right? So these are the examples of the Likert scale. Here there is some discussion is being involved. Normally the students of the economics and even the students of the pure sciences don't consider the interval data as the metric data. But in the field of management and in the field of social sciences, this interval data is being considered as the metric data. This is the measuring data of the lowest order. right? So this is the interval scale. Now, since this is metric data, so we can use mean, so to represent the central tendency. We can use variance or standard deviation, so to represent the dispersion. We can use Karl-Pearson correlation coefficient, that is denoted by R. We can use Karl-Pearson correlation coefficient. And here we can use both type of tests, parametric as well as non-parametric test. So these are the interval scale. Right? This is the example of the interval scale. Suppose I draw this. Just I am drawing 5-point scale. So this is highly dissatisfied, dissatisfied, neutral, satisfied, highly satisfied. And these are the 1, 2, 3, 4, 5, right? So this is an example of the interval data. But this scale does not have the ratio property. Ratio property means 2 cannot be regarded as twice of 1, or 4 cannot be regarded as twice of 2, or 5 cannot be regarded as 5 times of 1. So the last scale comes out to be ratio scale, right? Which has all the properties. Now it has naming, it has order, it has difference, and it also has ratio also, right? So all the real measurement like the monetary value, our height, our weight, all comes under the ratio scale. So this is also a metric scale. And all the tools that are there in the interval scale, they are applicable here also. So the question arises, in what manner interval and means how can we differentiate between interval and the ratio scale? In the ratio scale, there is an absolute 0. Means non-presence will always be denoted by 0, or the minimum value would always be 0. But here as you can check here, the minimum value is 1. The origin or the base, this is absolute 0 or absolute origin. Here the origin is 1 only. And it doesn't matter if we write this scale as 0, 1, 2, 3, 4, right? So there is no impact on the concept of interval scale. But here I am starting it with the origin as 0. So we can always change the origin, right? Means origin can be a local origin, but it is not a global origin. So here we have a global origin. Means this origin would remain same everywhere. But here we have local origin. Means some person can start it from 1. Some other person can start it from 0. Some other person can start it from -2. It can be -2, -1, 0, 1, and 2. Here also the difference remains the same, right? So this is the difference. In statistics, in SPSS, all these two scales, since the same number of the same tools can be applied to interval as well as the ratio scale. So they are being denoted by scale. So when you go with the SPSS, then we get only 3 types of scale. One is nominal, ordinal, and the scale. Scale constituted of interval as well as ratio scale. It covers both the things. So these are the 4 scales, right? The tools that are applicable to interval scale would be applicable to ratio scale also. So hopefully these concepts related to scales are clear to all of you. Hopefully they are clear to all of you. Okay, thank you. Right. Now, I always say that in the age of software and in the age of the languages, right? Sometimes we believe that everything is software, but actually the everything is not the software. Software, just a role of the software is just to facilitate the analysis. Okay, right? So it is always recommended that you should know the concept, right? Software may be changed, languages may be changed. Anyway, so that's why we always define data analysis. What is the main objective of the data analysis is to draw meaningful information from large mass of the data, right? Remember, I have used the word meaning. So this is the meaningful information. Obviously, the different persons would have different thing that is related to meaning. My meaning may be different from your meaning. So it depends upon the objective. Right? So we always say that data analysis is not an isolated activity. All the steps that are there in a research process that comes before the data analysis, our analysis is actually based upon that only. So the data analysis is a function of objectives, research questions, hypothesis, what sampling method you use, which type of measurement and scaling technique is being used, as I have explained earlier also, and by which method data collection is being done, right? So this is a function of this term, means any of these features, any of these variables got changed, any of these things got changed, right? There will be a change in the data analysis. So that's why we should be very careful when we go with the data analysis, that everything that is being done earlier would be there here also. Right? So we cannot plan the analysis in isolation. It depends upon all the future steps. Okay. So since the earlier resource person has made the things very clear to all of you that is related to SPSS Windows, so I am skipping that part. Anyway, I will be sharing the slide, so you can always go with this these slides if you face any problem. Right? So now we are going to discuss exploratory data analysis. We also say this in the form of data screening. Right. So what do we mean by data screening? Here I always take an example. All of you have seen the sci-fi movies or movies related to space or anything. So whenever a machine or any extraterrestrial body comes on the Earth, so whenever that machine or extraterrestrial body meets a Homo sapien or a human, what is the first thing that is visible to you, right? So that much in the screen you see, there's a screen where every information related to that person are visible, right? So that comes in front of that machine or the extraterrestrial body, right? This is known as screening or scanning of that person by that machine. The same concept would be used whenever some data is in front of us, right? So that's why we use the word data screening or data scanning, right? So this is the first acquaintance of the data by the researcher, right? So so this is the concept, the objective of the machine when it scans a human, an objective of the researcher or the data analyst whenever some data is in front of them are the same. So what are the objectives? Number one, whenever you meet a new person, right, your mind screen that person, and if that person looks to be proper, that person looks to be compatible, looks to be okay, then we smile at that person. Otherwise, we avoid that person, right? So this is known as data examination of the data or data examination, right? We examine the person that is in front of us, means whether that person is of good quality or not. The same thing happens with the data. So whenever some data is in front of you, we examine whether the data is of good quality or not. Otherwise, garbage in is garbage out, right? And the second thing is, just like the machine or the extraterrestrial body, we want to summarize that person. We want to describe that person. So here the objective is to describe the data that comes in front of us, right? We want to describe that person. So these are the two objectives for which we perform environmental scanning, environmental reading, data screening, or exploratory data analysis, right? And these are the different measures that we use so to describe as well as to examine the quality of the data. Here, whenever some data is in front of you, the first default property is that data must be similar in some aspect. Why data must be similar in some aspect? Because data has been collected as per some objective, as per some research question, as per some business question. So there will be a similarity in the data. So whenever a data comes, we always believe that data would be similar in some aspect. Like all the participants that are there in this FDP are similar in some aspect. All are in the academics or all wants to enter in the field of academics, right? All of us wants to learn research methodology or data analysis. So this is a similarity. So data must be similar in some aspect. And this similarity is being examined or calculated by central tendency. So objective of the central tendency is just to examine the similarity, overall tendency, or the general tendency of the data, right? Since the similarity may have different meaning for the different situations, so we have a number of tools that are there that we'll be discussing during the case. So the first property would always be there. The data is similar in some aspect. Now, along with the similarity, the second default thing is data must be dissimilar also in some aspect. So whenever we collect data, it along with the similarity, there must be some dissimilarity or dispersion or variability or heterogeneity that is related to data. So this is a second measure which actually denotes the dissimilarity in the data. Right? So it represents the dissimilarity. After that, we have two more measures. They are related to the shape of the distribution. One is skewness. Skewness is related to symmetricity. Means whether the data is being spread out in a symmetric manner. And the next one is the kurtosis, that is known as flatness or peakedness of the data distribution, right? So these are the four measures that we examine for all type of data. The first one is the central tendency that represents the similarity part. The second one is dissimilarity. Second one is dispersion, which represents or which measures the dissimilarity. After that, we have two shape parameters, two coefficient related to the shape that is known as skewness as well as kurtosis. And then we have some visualization, diagrams, and the graph also. So all these things constitute exploratory data analysis. So any question up to this point, I will be showing all these things. Any question up to this point, or the things are clear? Okay. So now we are moving for the data examination part, means whether we are examining quality of the data. Whether data is of good quality or not. So whenever we consider the data examination, right, that is related to the quality of the data, we actually concerned with three parts. Number one, related to the missing observations, whether our data has a large volume of the missing observation or missing observation can be handled easy. The second thing is whether our data is having outliers or extreme values. Okay. And the third aspect is that is related to some assumptions that are inherent in the data. Okay. Okay. So these are the three aspects that we always examine whenever we consider the quality of the data, right? So now how they can be examined, right? So now I am taking an example, right? Then I will be going back to these concepts so that would be explained in that manner. Okay. So I am changing my screen. So this SPSS sheet is there. So before going with this, let me introduce you the case that I am dealing here. So this case is being shared with all of you. It is related to Ventura. So this case, through this case, I will be dealing with the EDA part. And after that, the testing of hypothesis part also. So the case is like that Ventura is a company which has 1150 sales executives belonging to the different 1150 different outlets. Means sales executive and outlets we are using interchangeably. They represent the same thing. A sample of 60 sales executives have been found are there, right? And some information is being collected from these 60 executives, right? It means the information that we have at present is related to these 60 executives. And whatever the things that we are going to do, whatever the analysis that we are going to do would be through these 60 people, but it should be applicable to the entire 1150 outlets. So all of you must remember this aspect that we are going to discuss, right? And what are the variables that are there? The first variable is the location of the executive, that is whether that executive or outlet belongs to northern region, eastern region, western region, and southern region, right? Here, northern region is being represented by 1, eastern by 2, western by 3, and the southern region. The second variable is related to the type of outlet, where the outlet belongs to the urban area, is that outlet caters to the urban area, or that outlet caters to the rural area. Here the codes are being used as 1 and 2. So as you can check that variable 1 and variable 2 is categorical in nature. So this is the nominal data that we are going to use for 1 and 2. After that, we have 4 variables. That is the sales of the outlet in the first quarter in the form of thousands of rupees. Then we have Q2 sales, then we have Q3 sales, and after that we have Q4 sales. So the first task is related to presenting the data. So the first task is related to developing the comprehensive report. And after that, there are 2 things that we will be discussing later on. Right? So this is the case that is there in front of you. So hopefully all of you are clear about the case. All of you must be clear about the case. Okay. Right. Now I am discussing the aspects that is related to the exploratory data analysis part. So just a question, have you people gone through these tools? That comes under descriptive statistics like frequency, descriptive, and explore. Okay. So all of you have gone through that? Okay. So explore has been discussed. Fine. Right. So I am not going with the basic one, that is the frequency and the descriptive. I am taking up the explore, and through that, I will be establishing some concepts that would be useful for the testing of hypothesis. Okay. Just for the demonstration purpose, I am taking these 2 outlets, that is the sales of the outlet in the first quarter and sales of the outlet in the second quarter, just for the demonstration purpose. And here, I am taking, along with the descriptive, I am also considering some measures that are M estimators and outliers, just to demonstrate something. And I will be plotting box plot, stem and leaf, and the next one is related to histogram. Right? Histogram is not required, so I am leaving that. And then we have the normality plots. Right? So I will be discussing all these aspects here. And then we press OK. So now, here we are having the first part. The first part where we have information like, we have valid information, then we have missing information, then we have total. So what is the objective of this part? This part is used just to examine what is the volume of the missing observation, whether the missing observations are large or missing observations are not so large. So this is the first quality check that we perform with the data, whether the data is of good quality or not. So before moving forward, I am taking this part that is related to volume or the problem related to missing observations. So related to, so now I am using the PPT, hopefully it is there, examining the quality of the data. Means whether the large volume of missing observations are there or not. Why this is important? Suppose we have taken a particular sample size, that is n. And for that analysis, this sample size n appears to be good, appears to be okay. Right? Suppose we have a sample size of 100. And now, in this sample, suppose 40 observations are missing. So we have an effective sample size of only 60 only. Means that anything that we are going to use, anything that we are going to analyze is based upon these 60 observations only. So the effective sample size decreases, means there may be issue related to the output or the inferences that we draw. So it has an impact upon the generalization. So it is a problem with the missing observation. Now here, two things are important. Number one, volume of the missing observation. Obviously, if the missing observations are large, then there will be an issue related to quality of the data. And the second thing is that is related to pattern of the missing observation. If the pattern of the missing observation is non-random, it is well defined, right? Then there is a question mark. Even if we don't have large volume of the missing observation, but if we have non-random or well-defined absence of the data, it represents something. Means there is some defined cause, some defining cause is there, right? So there may be an issue. So whenever some missing observation is there, we examine two things. Number one, what is the volume of the missing observation? And the second thing is, what is the pattern of the missing observation? Okay. Now, suppose if we have missing observation, then what can we do? This is known as missing value imputation. So the most basic method is we can drop the missing observations, right? But if we drop the missing observation, then obviously there will be a loss of data, right? So the other approach is we can replace the missing observation, that is known as imputation technique. And what methods are being used? We can go with the mean, we can go with the median, right? Or we can go with the linear trend, interpolation and extrapolation, right? So how we decide that which method is to be used? Suppose we have missing observation and our data is cross-sectional in nature. One-time data is there. Then either we go imputation with mean or we can go imputation with median. Right? If our data is having an outlier, then we go with the median. Otherwise, we can use the mean. Okay. But if our data is longitudinal in nature, then we can make use of interpolation in linear trend or interpolation, right? So these two approaches are being used when we have longitudinal data. So these are the imputation techniques. Now, a big question arises, decision should be made whether to use imputation or not. Means whether imputation makes sense or not. Let us take an example. The same example. Suppose in 100, the missing observations are 40. So the volume of the missing observation is 40%. Now my question is whether some imputation technique means replacing all the missing observation by mean, suppose there is no outlier, should be used or not. Yes. I'm repeating my question. You can answer in the chat. Suppose we have 40% of the missing observations are there. Right? My question is whether some imputation technique should be used or not. Imputation means replacing missing observation by some center tendency value. Should be done or not? You can answer in the chat. Okay, yes, yes. There are two answers, three answers. Yes. Okay, one more answer. No, good. Not sure. Okay. Now, why we are having divergent? If we don't impute, then there will be a major loss of the data. 40% data would be lost. Okay. So this aspect is being this logic can be used by all those who give the answer yes, right? That we should impute. But now the reverse side. Suppose if we impute all the observation by 40. So if we impute all the observation by all the 40% observation by mean, so 40% observation would become exactly similar. Okay? Since 40% observations are being denoted as similar, it means there is a loss of variance in the data, loss of variability in the data. And loss of variance means information is being lost, right? Now, everything appears to be the same, so the variability is being lost. So no one can give the definite answer in this case, right? Whether we go for the imputation or we shouldn't go for the imputation. If we go with the imputation, then there are certain issues. And if we don't go with the imputation, there are some different issues. So that's why the discretion of researcher comes handy whenever we decide whether to impute or not to impute. Right? So this is related to missing observations. Okay, so we have discussed related to a number of missing observations or the volume of the missing observation. Now I am coming for the second examination that is there, that is related to outliers. Right? How we define the outliers? Outliers or the extreme values, they are distinctly different from others. So as the name suggests, that anything that is standing outside, right, that is known as outlier. So always there are questions whether the outliers are to be retained or outliers are to be eliminated, right? So this is a point of discussion in all the analysis, right? And these are the different reasons. I am not going in that detail. Now, how can we examine that in our data outliers are there or not? So the first one is related to the univariate detection of the outlier when we consider only one variable at a time, right? So the first comparison is mean and median. Since all of you must be knowing that mean is badly affected by outlier and median being the middlemost value, there is no impact on the outlier. So if there is a large difference between mean and median, right? If there is a large difference between mean and median, it is being suggested that outliers may be there. In the same manner, there is a term that is known as 5% trimmed mean. What do we mean by 5% trimmed mean? Suppose this is the data that is being arranged, right? This is the minimum observation. This is the maximum observation. So for the 5% trimmed mean, 5% lower values and 5% upper values are being trimmed. So we calculate mean only from 90% of the middle data. So what are the things are there? If outliers are there, so outliers would either be on this lower side or outliers would be on this higher side. So by the trimming, outliers may be deleted. So again, if there is a major difference between mean and 5% trimmed mean, we can say outliers are there, right? The third comparison can be on the basis of these two things, that is the mean and M estimator. M estimators are also known as robust estimators. So these estimators are minimum being affected by the outliers or the extreme value. So there is no impact of outliers on M estimator. So again, if there's a major difference between mean and M estimator, they all represent the presence of an outlier. The second concept is related to the standardized score, that is the Z-score. How the Z-score is being calculated? All of you who have gone through the normal distribution, they know the formula that this is x minus mu upon sigma. Means we subtract mean and divide it by standard deviation. So values are being converted to Z scale, right? So the Z scale lies in between +3 and -3. What do we mean by lies in between? So 99.73% of the observation would be in between -3 to +3. So Z-score can also be used so to examine whether outliers are there or not. So for a small sample, all the values that goes beyond ±0.25 are taken an outlier. And for a large sample, these are the thumb rules that all the outliers, all the values that goes beyond ±4 are considered as an outlier. Now, now there is a problem with the Z-score. Z-score should be used only in the situation if the data is normally distributed. We will be discussing this concept is normally distributed. But if data is not normally distributed, we shouldn't use box plot. So in statistics, in analytics, the most popular method is box plot. Right? Now I'm explaining what do we mean by box plot. Just a moment. Some of you might be familiar with this. So actually, a box plot consists of two boxes and two whiskers. These are the two whiskers. This represent the position of Q1, means 25% of the observations are below it. It represents the median. So 50% of the observations are below it. This is Q3, means 75% of the observations are above. This Q1 is also known as lower quartile. And this is also known as upper quartile. Okay, means 25% this, 25% this. Now, this value is at a difference of 1.0 interquartile range. So interquartile range is actually the difference of Q3 minus Q1, right? So this gap is at a difference of 1.0 interquartile range. Means this value is Q1. So this is a lower value. It would be Q1 minus 1.0 IQR. Okay, right? So in the same manner, here also, this gap is 1.0 IQR. So it would be Q3 plus 1.0 into IQR. Okay, so these values are being decided. Right? After that, we go beyond that. Means we go up to this part. This part is 0.5 IQR here. And this part is also 0.5 IQR here. Means this is the position of, or should we take this first? This is the position of Q1 minus 1.5 IQR. And this is the position that is Q3 plus 1.5 IQR. Okay. So any value lie in this blue region are taken as an outliers. Right? So any value lies in between these blue regions or in between 1 to 1.5 IQR are being taken as an outlier. Okay. And if we go beyond that, like here or like here, Means this green part is greater than 1.5 IQR, right? Means it is less than Q1 minus 1.5 IQR, or here Q3 plus 1.5 IQR. Means anything that lies beyond 1.5 IQR from Q1 or Q3 are, these green things are taken as an extreme value. They are taken as extreme value. And then you can check the notation also. I am using the star. This is known as extreme value. This is also known as extreme value. So anything that goes beyond 1.5 IQR on the either side would be taken as extreme value, right? So far I am using both the things, outlier and extreme value, interchangeably, but here I am distinguishing them between outliers and extreme value. So extreme value are far, outliers are not that far, right? So if our data is having extreme value, it must be deleted, it must be removed. If our data is having outlier, then they may be retained and they may not be retained, right? So here, as you can check, this I have explained the concept of outlier as well as extreme value, right? So this is a very important tool that we use even in statistics, even in analytics also. Whenever we have pandas, so through the pandas, we create this data frame, and using Seaborn library, we make the box plot and check whether our data is having outliers or not. So this is the concept that is related to box and plot, where we use box plot so to examine whether the outliers are there or not. So hopefully this concept is clear to all of you. This concept of outlier and extreme values, I will be showing all these things to you. Okay.